So now we're going to talk about half-lives. Nuclear half-lives have to do with when an element is spontaneously decaying and it's releasing radiation. Once it reaches its half-life, it now has become stable. So a nuclear half-life is the time, it's a measurement of time it takes for an isotope's mass to be reduced by half. So it's the time it takes an isotope, that weight, for that weight to be cut in half. So for example, if you have 100 grams of carbon isotope, how long is it going to take for it to get to 50 grams? The thing about half-lives, if you graph it, is it looks like this. It is not a linear decreasing graph. It is not this. And because it is not linear, you cannot use a ratio to find this. That's the first instinct of most students. They want to use a ratio, mass over time equals mass over time, to figure out the half-life and solve these equations. You cannot do that because it's not linear. The mass is going to decrease very quickly at first, and then it goes slowly and slowly. So the rate of decrease is not constant. You cannot use that ratio. So what you're going to do is you're going to decrease it by half and count how many times it decreases. So let me show you. So it says how long, so we're looking for time, does it take 100 grams of astatine 81 to decay to 6.25 grams if the half-life is 33 seconds. You're either going to calculate the half-life or you have to be given the half-life. That's not something that you memorize for each atom. So what I'm going to do is I'm going to start with 100 grams. And like it says, I'm going to cut it in half to 50 grams. And what we say is that is the first half-life. So in the first half-life, it went from 100 to 50. And then I'm going to cut 50 in half to get 25. That's the second half-life. 25 in half to get 12.5. There's the third. And then when you do 12.5 in half, you get 6.25. Which is what the problem's asking for. That was the fourth half-life. It's always going to work out like that. So what you look at is you have 1, 2, 3, 4 half-lives for it to reach 6.25. So then what you do with that information is, now you can say if one half-life is 33 seconds, well, I just take that 33 seconds and I multiply that by 4, because there was 4 half-lives to get to 6.25, and I get a total of 132 seconds. So instead of doing a ratio, you're going to count the number of half-lives. You're going to keep decreasing the mass by half and count how many that goes through. Okay, the next problem, what is the half-life? So now you're going to calculate the half-life of an isotope if a 500 gram sample decays to 62.5 grams in 24.3 hours. So again, I'm always going to start the same way. I'm going to take 500 grams, cut it in half. There's the first half-life. Cut that in half to get 125. There's the second. Then cut that in half to get 62.5. There's the third, and that's what the problem's asking for, 62.5. So it takes 3 half-lives to get to 62.5. So then what I do now is I take the 24.3 total hours and I divide that by the number of half-lives 3 to get 8.1 hours as my half-life measurement. So again, notice what I did. I always take half, 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 and count how many half-life it gets to reach the designated amount. And then I'm either going to multiply by the hours if you're trying to get the total, or if you're trying to find the half-life, you take the total and divide by the number of half-lives. So if we do 15, it says the half-life of radon is 3.8 days. How much of a 100 gram sample is left after 15.2 days? So we're going to do things a little bit different here. Because you're given 2 times, what you're going to do is take 15.2 days and divide that by the half-life, 3.8, and that's going to give you that this thing is going to decay 4 times in that length of time. So if each half-life takes 3.8 days, well, in 15.2 days, you can reach 4 half-lives. And then I do my mass. I start with 100 grams, Divide that by half. There's your first. Half again. There's your second. Half again. There's your third. And then the fourth, which is what it asked for. There it is. So in 4 half-lives, you're going to get 6.25 grams. Okay, so carbon-14 has a half-life of 5,730 years. If a sample of 70 milligrams originally, how much is left after 17,190 years? So it's very similar to the one we just did. If you're given 2 times, you're going to take those 2 times and you're going to divide them. You're going to divide by the half-life to figure out how many half-lives you can go through in that given time. So we're going to figure it's 3 this time. So then I take my original amount, 70 milligrams, and I'm going to divide it in half 3 times because it goes through 3 half-lives to get my final amount. So the first division is going to be 35 milligrams. There's 1. Then we're 17.5 milligrams. There's 2. And then the third one is going to give me my answer, 8.75 milligrams in 3 half-lives. And finally, it says how much of a 500-gram sample is left after 62 hours if the half-life is 12.4 hours. So again, you're given 2 times. So I got to take that 62 and divide that by the half-life, 12.4, to get 5. You're going to be able to go through 5 half-lives. I take my starting sample, 500 grams, and I'm going to have to divide it in half 5 times. So I do 250 first, 125 second, 62.5 third, 31.25 fourth, and this last one will be the 5th, so it's going to give me my answer, 15.625 grams. So after 5 half-lives, you'll have 15.625 grams remaining.